back. On Simon.
Okay, so this is year 9. Thank you for waiting. I'm happy to see you here. Today we are doing some compound measurements. Compound measurement is very important when you study in year 10 and 11. Because we are starting from here with some things more than what you need. So for example, previously you just learned about PM, PM squared, PM cubed, and now we have increased and changed to somewhere which is more than one type of unit. So an example will be speed. Speed is something. Can you say speed is a meter? Can you say speed is a time? No. Speed is that. For example, when you go from one point A, go to another point B. Okay. The distance is 100 km. And then you took this journey for 2 hours. So if you divide 100 km into 2 hours, roughly you know that this is actually 50 km over 1 hour, or you can write this as 50 km per hour, or you can write it as 50 km hour negative 1. So to this, as compared to 100 km, you only have 1 unit. For hour, you also have 1 unit. Okay, Mr. Hallie Clement would like to tell you that. Can you see, notice that you have the km and hour both in the speed. So this may be a compound measurement. So we have to learn this one in our physics later, economic later, okay, but geography also, but most of the time it will be in the physics. Okay, for example, the speed is the distance over time. Okay, so the distance will be m, the time will be s, for example, meter over second, or km over hour, or you can say this is meter per second, kilometer per hour. Okay, and then density. Density is another chapter in the physics. This is how many kg, the mass over some volume. So you may have kilogram per cubic meter, gram per cubic centimeter. Pressure. Pressure is how much of the force that you can apply to some area. So the unit for that is a Newton, the force per square meters. Fuel economy, yes, this is when you learn about financial things. So how many km can you run by 1 liter? So it's a km per liter. Population density, this is how many people are there staying in the 1 kilometer square. So for me, I think your school have teach this triangle. And usually I don't like this triangle. That's why I will skip this one. Okay, nah? Because I prefer you to approach this one using the physics way, geography way instead. I mean, which is to understand the logic behind that instead of the memorizing. Then we go for a practical question, which is value for money. Okay, compound mention are used in value for money comparisons. There are two ways of comparing two items to see which is the best value for money. You can work out the cost per item or unit of mass, capacity, volume, or you can work out the number of items or mass or capacity you can buy per cost. Have you ever gone into a store and seen two signs like this? I think you have, huh? Okay. I think you have, right? Okay, it means that 4 pair of socks cost 28, 6 pair cost 43. Okay, so which one is cheaper? So to work out this, you need to find the cost of single pair. Okay, so you take this one. 43.8 divided by 6, you get this is 7.3. Actually, you can have per one sock, one pair of socks, okay? So if you get the second one, this is the 28.4 divided by 4, you get this is 7 and 10 per one pair of socks. So usually we may think that buying more, you get a cheaper price. But here you know that buying more, each one is 730, whereas buying less is 710. So which one will you look for? You always think that buying 6 is cheaper, or you like to learn this mathematics, so that after calculation, you know that, oh my God, it's a 4 pair, which is cheaper, can you see? Yes, huh? So not only for socks that, okay, we also need to compare for other things. For example, we have the median support. This is 0.5, which is 2.2. This is 2 kg, 8.7. Okay, which one is better to buy? The extra large one holds 2 kg for this one. So 1 kg is around 4.35. The median size is 0.5 for 2.2. So 1 kg is 2 pack. Like buy 2 pack, so they can go 1 kg is 4.4. So this one is a cost about 4.4. This one 4.35. So this is cheaper. But this book is interesting, you see. Hence, it is cheaper to purchase the extra large size. Okay. Black cat, if you can afford it. Okay. Interesting book, right? Okay. Example 3 shows how to work out the compound measure in dollars per kg. You saw that you cost each one, you can compare. Okay. Costing the item, the kilogram per dollar, which soap powder in example is better to buy? So 2 kg. So if you compare the other way, the extra large soap cost this one for 2 kg. So $1 you get 0.230 kg. The medium size cost $1 you get 0.227. Okay. So which one you spend the money can get more? It's cheaper. The extra large one, okay. Hence, the extra large size give you a greater mass of soap or powder of each dollar spent. So you can compare two ways, You can compare, how much you can buy using the same amount of money. Okay. Or to buy the same amount of the 1 kg, for example, of the soap, which one costs cheaper? Okay. This one, same money, buy more. This one, same volume, same mass, buy cheaper. Okay. So yesterday, year 8, I also do the DRI graph. I think you can always go back to if you want, okay? But today, we should look at something, which is the travel graph here. Okay, travel graph, okay? So this is distance, and then this is speed, okay? So the gradient for the distance kind graph is the speed, and then the gradient for the speed kind graph is the acceleration. Okay, so the gradient, okay? So let's see. Acceleration is the measurement, the rate of the speed is increasing, whereas deceleration is a measure the rate, the speed is decreasing, okay? So let's try to see this one. Is it possible to tell by looking at the graph when the car is traveling at higher speeds? It's traveling faster when the graph is at the steepest. It means that, can you see? Within the same time, the change of the distance is 50. Within the same time, can you see 1 hour, 50, but this 1 hour from 50 to 150, so it's 100, you know. So 1 hour, this is driving very fast. And then this B point. This point is that 1 hour, you're still at the stationary point, you know, you are stopped there. Maybe you are eating your lunch. Then after your lunch, then you have get energized, then you can get focused, a cup of coffee, then you can drive fast. 1 hour for 100 km, and lastly, you take slow. Okay, why? Maybe the traffic jam. There's only 1.5 hours, but you only drive about 50. You see, so the gradient here will show you how fast is the speed. So the more the gradient, the steeper, the faster, and then the less steeper. Okay, so this is slower. And then when this is horizontal, it means the car is stopped. So here, if we have the speed time graph, the gradient will show you the acceleration. Okay, so average speed for this one is, can you see the final one, 70 plus the 31, then you average it to get a 50. So the distance travel for this graph, actually, distance travel is the area covered. The area covered. So which is the average speed. Okay, we will cut this one. This triangle here to cut the period. This is a rectangle, right? So average speed is 50, and then times the time is 5. So altogether you have drive for 250 km. The acceleration is a change in speed, which is a gradient. So for 5 hours, this is 5 hours, and then the change is from 7 to 30 to 7. So we increase by 40. So divide by 5 hours. So every hour I increase by 8 km. Of the speed, okay? The speed increase. So every hour, I increase the speed by 8 km per hour. So initially, for example, maybe my speed is 30 km per hour. 1 hour later, 38. 1 hour later, 46. 1 hour later, can you see I add up another 8, which is a 54. So I'm driving faster and faster and faster. So if this graph, when we change it to the distance curve, is like that. Oh, so the first one, second one, third one. Oh, can you see the speed is like the distance is like every single. Can you see the distance? It increased very much. Can you see? Okay, so in the distance time graph, it looked like a curve. Okay, exponential curve. So the distance is the area under the speed time graph. Can you see? This is what I show you. Another way you can use this is trapezium. So this is 30, this is the two parallel line, 30 and 70 need to pass together and then divide into 2, which is a 50 as well here. Then times the times the perpendicular height, okay, which is 5, so you get 250 km. We have other graph, okay, we have other type graph, okay. So I think we can go through some of the exercise, okay, and have a look with that, okay. Here is a distance time graph for a car's journey. Graph of a car's journey. So this is distance. You can see you must be careful. No? Sometimes this is distance, sometimes this is speed. Find the gradient of the line in segment OA. Okay, so OA. So the gradient, yeah. Okay. Gradient, I want you to write this one. Gradient is the difference of y over the difference of x. So the y difference from OA. So you can see the y here is from 0 to 20, so it's 20. And then the 0 to 1, so it's 1. So the gradient is 20 km per hour. So gradient for OAB. Okay, let's see. Let's see we find the BC lah. BC will do. BC. No, the BC is done for you. Okay. So we done the AB. Okay, AB will do. AB. So from 20 to 60. So 60 minus 20, which is 40. Divide by 2 minus 1. 2 minus 1. We get 1. So it actually is 40 km per hour. Then we can find the EF. Oh, so the EF, EF, the F, the Y, the speed, the distance is 20, 200 minus 200 over this is 5 over 6. So this is 0 over 1. So 0 over 1 is 0 lah. It means that 0 km per hour. So EF means that the car stopped there already. So we call this is stationary with 1 hour. Okay. We'll try to see this one. The graph shows that the speed of the particle over a 15-second time. What was the acceleration of the particle during the first 2 years? Can you see? This is a speed time graph, right? It's not distance time graph. So the gradient of the speed time graph, is acceleration. So acceleration is equal to gradient of the speed time graph, which is now you need to find the first 2. So this is from 0 to 50, so it's 50. 0 to 2, so it's 2. So it's 25 meter per second. Okay. You need to copy the meter, this one over this one. Okay. During the next 3 seconds, so now you need to find this one, 7. Okay, next 3 seconds is D, number 2. Is that 50 to 70? So you have the 70 minus 50, and that time will be from 2 to 5. So it's 5 minus 2. You get 20 over 3. So your answer is 6.667 meter per second squared. Okay, then you can find the deceleration, which is the last one. Here the speed, okay, number 3, during the 6 seconds after that, this 6 seconds from 5 to 11, actually, this is flat. It means that you are driving at a 70 speed constantly. Okay. So for this 6 hours times 70. So within this period, from 2 to 11, I think you have driving about 420 meter away already per second, per 6 seconds. Okay. So the B, deceleration is the same thing. Deceleration is the same thing. It's about, can you see now? The change is from the 70 to 0. So it's a 0 to 70. The finishing minus the original one. Divide by the time, which is a 15 minus the 11. So it's negative 70 divided by 4. So your answer is negative 18.2. 0.2. 70 divided by 4. Oh, 5, or 18.5, sorry. So this negative means that the particle is moving slow down. Okay. Then we have other time graph. For example, this is cost and the number of text messenger. Sometimes the ticket, sometimes the fuels, sometimes the payment you need to pay. Okay. Okay, for example, we look at this car, Mr. Patel bought a new motorhome at the same time as the Mr. Temple bought another one second-hand. So second-hand cost this one cost this one. So apparently when the two motor worth the same amount, yeah, this is the time 2011 and in the June that they have the same price already. Whose motorhome has depreciated more quickly? Which one the money drop faster? Yeah, the bit Patel also because new car, you see every year they drop so much. Okay. What was the approximate difference in value between one after? What was the approximate difference in the value between the two motorhomes? 1 year. 1 year is this one, so you need to find this number minus this number. Okay, now work out the division rate of each motorhome. Then you need to find the gradient. Okay, so you need to find the price for the Patel. This one minus this one over the time, and then for temperament, this one this one minus this one. Sorry, the lower one minus the latest one minus the original one, the later one original one, and divide by the time. Okay, so this is Mr. Henry Clement. I hope that you have done this your year 9, and then if you need other thing to help, or I can provide my service, let me know. Okay, hope you enjoyed this class today. This morning we have the neutralization and the reaction with the acid and alkaline. If you like, you can go back. Always go back to the YouTube. Okay, and then ask your friend to like subscribe our page, because now I'm still using I'm still live with I cannot using live using my handphone. I think it's not convenient. You can ask your friend to like me and share my video so that there will be more like and more subscribers, so that I can do it anytime, everywhere when I have free using my handphone. No need to stay at my office so that to use the computer and the internet so that to do the live stream on YouTube. So thank you for your help. Thank you very much. Bye.